So this the idea here was that these experiments were purportedly uh, thought to reflect evidence that we are representing things, imagistically. We have spatial representations, and then this cognitive scientist, I believe his name is Zenon Pelishin. I'm not sure. Sounds like a Star Trek character. But he's really big on propositional representations, and he's kind of the contrarian uh, that, whenever I read anybody arguing against the idea of mental representations or visual mental representations, it's usually this guy's either the one doing it or he's getting cited heavily. And his idea was, well, you could still get the same results uh, with symbolic or propositional representations if you assume that you have to scan more nodes. You have to go through more conceptual nodes when they're farther away, just like that picture I showed you with ChatGPT, right? So here's the example. If this is like a motor, right, and then propellers in the bottom of the motor, the handle is in front of the motor, the rear deck is in the rear part of the motor, I guess. Uh, the rear deck is behind the cabin, the windshield is on top front of the cabin, and porthole is on the side of the cabin's behind the front deck, and the anchor is attached to the front deck. And so if the propositions, or if the nodes, conceptual nodes or units are organized in this fashion, you could get similar results. So for example, if you have motor, right? If motor gets activated, that's what that sort of yellow fire thing is supposed to represent. Then that activation should take longer, let's say, to when it has to travel farther away. So let's see. The argument is the reason it takes longer, for example, is that activation must travel a longer distance or through more nodes, right? And in the example, actual distance of the actual image was related to RT, but maybe the nodes are also organized in a similar way. So yeah, like a symbolic or propositional representation could explain these effects by assuming that you have to scan through more items when they are farther away. And so, um, for example, if you activate motor, right? If you're at the motor and you activate it, then it'll take that amount of time, however much time that took for activation to spread from motor to porthole, right? So from going from motor to porthole will take that much time, whatever that is. But going from motor to anchor, that should take more time because it's farther away, right? So here's porthole, that doesn't take that much time. But then motor to anchor, that's more distance or more intervening nodes that could, and therefore reaction time or verification time should take longer if this is how the nodes or concepts are organized. Of course, these distances could be due to so it could be that um, the RT effects could be due to actual spatial distance in the image, right? Or it could be the number of intervening items. So the propositional account would say that that difference in RT, in verification time, reaction time, is due to the fact that the activation has to spread uh, through and sorry, it has to spread to more. It has to. That's oh my God. I'm sorry. That activation has to spread and traverse through more nodes. And that's what explains the difference in verification time, whereas the spatial um, argument that these are actual visual mental representations would say that it's because of the actual distance. And so follow-up experiments tried to manipulate spatial distancing without also manipulating the number of intervening items. So that's the confound in this kind of experiment, is that the number of intervening items is greater with more distance. So to go from motor to anchor, you have to not only is it farther away than, say, motor and porthole, but you also have to, if it's propositional, you would have to go through more nodes uh, to get to anchor than for porthole. So what you want to do is, if you want to test the spatial versus propositional account, then you should deconfound those two variables or manipulate those two things independently, or at least control for one of them. And so that's what this experiment tried to do. Um, and so here, the idea was you have an island, right? And what you're going to do is you're going to traverse from one part of this island to another part of the island in your head, potentially. And so you're here, and then it says, okay, go to here. And that should take less time than if I have to go all the way there up at the top, right? So you start here, and it should take less time to go from where this red dot is now to where it is now compared to where it is now, right? And in doing this, you don't have to traverse through multiple positions in order to get uh, to that other spot, right? So in this example, the idea is that the actual distance is what's being manipulated, and there are no intervening nodes in this example, right? To get from here, where this red dot is, to here, there's no nodes involved. Whereas to get from here, and also to get from here to to get from to get from there to here, it takes, there's no nodes to go through. It's just actual distance, pure distance that you're manipulating here. Okay. And what they found was that the reaction time, how much time it took to get from point A to point B in your mind, uh, it increased uh, quite systematically with the distance from point A to point B, right? So, yeah. And so this is difficult to explain with symbolic or propositional representations. Okay, next video we'll talk about what you may be finding unconvincing about these experiments, uh, and then a nice, clever experiment to that was well designed and doesn't have the same problems.